Hi, everyone. We'll give it a few minutes and then we'll get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Network, welcome to the final webinar in our on-site wastewater webinar series. Today's session is on optimizing on-site wastewater systems. My name is Owen Volk from the Syracuse University Environmental Finance Center Network. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information you may need. You can also download the slides from today's presentation in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, I would like to get started. I would like to introduce our presenters for today, Dr. Jason Barrett, who is the Associate Extension Professor and the Associate Director at the Mississippi Water Resources Research Institute at Mississippi State University. He will be joined today by Gregory Pearson, who is a water and wastewater trainer from the Great Lakes Environmental Infrastructure Center at Michigan Technological University. Welcome, Jason and Gregory. I will go ahead and hand it off to you.
All right. Can you hear me?
I can hear you. Yeah.
All right. What are we seeing, Owen? Owen, can you see me? Can you hear me?
I can see and hear you now.
Okay. All right. I'm gonna minimize. I can minimize this view. There we go. All right, good deal. So, hey, I'm Jason Barrett here with Mississippi State University Extension, the Water Resources Institute. As you heard Owen say, an associate extension professor here, currently the interim director. Our Institute director just left at the end of August to go pursue the private sector, and we're happy for him. We think it's all going to be great things. So for one, do realize we're being joined by Greg in the Great Lakes region. Greg and I several months back we're talking about how a lot of our trainings and topics overlap, so we wanted to put this sequence together. And I really viewed, where we are now with this fourth one is somewhat of an encore, somewhat of a closing of the loop. So I've pulled pieces from all of our presentations and just hitting on some key points. So if y'all recall from the initial announcement, we're going to look at the basic components of a system. Again, you've heard these, but we're just going to walk through it again. And my desire is for on each of these main 4 points, ask Greg to at least just give us, some thoughts or closing comment on each of these. Impact of actions. This is where we're going to look at the individual homeowners' actions and how they may impact the system. Then next, we're talking about how poor functioning systems, how they can truly affect the landscape. And, this is one of those words, when I teach class in environmental policy, when we talk about a landscape, we may be talking about a social landscape or a policy landscape, where in this case here, with more of my extension hat on, we're truly talking about the landscape. We're truly talking about the grass, the yard, adjacent to your property, or where the on-site wastewater system is. And then next, we're going to kind of close it out with how our systems can impact the private wells and what that looks like. And I truly think you got to have a cross section to get into that. All right, so the first piece that we're going to jump into, what are the basic components of an on-site wastewater system? I feel like I looked through all of our presentations that we've had up to this point. So I have a good feeling that y'all have seen all of these components before. So this is just, to me, a solidifying of the components, the operations, that what y'all may see. So when we look at a tank, and we're going to have some pictures here, but I'd ultimately like to say is, in a perfect world, this is what we have. This is not always what's actually in the ground, but we're trying to get to this process. And we've seen legislation passed in Mississippi to where we have certified inspectors, certified installers, so that we are getting the actual systems in the ground that need to be in the ground for collecting, treating, and disposal of the system. So just moving from left to right, and I know we'll talk about containers in another slide, what type you may see, but you're seeing where the influent comes in, and again, we'll get to the inlet pipe, that inlet T, and why we have that, we'll get to that in a minute. You talk about your risers that you can access the tanks in the different chambers. That is mission critical for the life of a tank, so you can actually pump it, clean it, keep that process rolling. Then when you look at your scum layer, the actual water layer, that clear layer, and then the sludge or the solids at the bottom, and then moving over, you'll have a baffle. Again, we'll talk about baffles in a minute, and then that outlet T where it's going out. These all serve a purpose. They're designed specifically to make this an optimal treatment system. And again, we will get into size a little bit later. But again, when we look at the perfect picture in my mind of what one would look like, we have this here. And then talking about our points, again, I said the different types, and we'll get into that in just a second. Thinking about our detention time and how long the actual influent comes in and remains in the tank before it flows or moves out. And then as far as the separation, we're using a very natural process to allow these solids to settle, that either aerobic or anaerobic digestion to happen. It's kind of this natural bacteria breakdown of our solids before moving into the next chamber for rolling out. All right, so we're talking about tanks. Y'all may recall from mine and Greg's presentations where we mentioned the different styles, different types, different materials, the concretes, the fiberglass, polyethylene or plastics. You know, a lot of what we tend to see from my extension hat are the actual plastic tanks, these polyethylene tanks. We see a lot of those. And I think it may be a matter of simply cost and still being able to get effective treatment. We just down the road here in the adjacent county, we have a concrete fabricator who makes these precast tanks. We do see a lot of those, at least being manufactured on our side. You know, to me, if I'm selling one of them, that's probably what I'm going to try to promote the most of. But from what I see, and I'm going to say this, from what I've seen from my extension years, the septic tanks that we've seen in the ground, if somebody will go to one of these, I'm excited because at least it's designed and truly built for wastewater treatment at the home level. So I am not going to really dig in and press people one way or the other. But as long as you stay in this mode of what is kind of the industry standards, I think you could be in good shape. All right. Y'all know me from the previous. I love pictures. I love cross section. I love very, very much visuals that we can have. So this is a very simple cross section so that you can see from your resident. You have this outflow pipe entering into the tank, in which will get your solids to settle out, moving into a distribution box, and then that splintering out into your drain field or leach field, whatever we may call it, allowing for some type of subsurface material under that. You may see gravel, you may see sand, you may just have natural soil. A lot of our state, when we get into like southern part, even though we're in we have some adjacent to the river, you may have a lot of sandy soils, so you may not need or may not want that subsurface material under there. But hopefully you're having some type of leaching into the soil, which will serve as a disinfectant before it reaches into the groundwater water table. So again, good cross section that I like to show. To me, this is a very simplistic view. And when we have our extension audiences and workshops, I think this bodes well because they start truly getting an understanding of how it is working, how the process is taking shape. All right, so a little more into the processes rolling in and thinking about why we have specific pieces to our tanks, our processes, the treatment itself. So from the inlet pipe coming in, I'm gonna say this, we have our T, and I'm gonna let Greg at least jump in if he wants to jump in. I know Greg has a lot of experience in this arena as well. So from the influent coming in, we want and like to have this T. So in my mind, we definitely don't want anything backing up into the system, and this can help us at least from a solid standpoint. If your scum layer starts to rise, if you have solids on top, allowing them not to get back in the system if there's some type of flow or issue. And then when we look at the actual baffle in the middle, if you notice from the previous tank we had, there was actually a kind of a slit divider, and this one we actually have a T or a pipe in the middle, but allowing that water to actually flow through. But again, we're really not wanting to see any of that scum layer solids, if possible, to move over into the second chamber if we can help it. And then when we get to the far right of the outflow effluent, you definitely want to make sure you have a T there, because you don't want your solids flowing into your distribution box or your drain field, because your drain field should be an area that's that allows for good percolation and allows for the water, the liquid, to come out of those leach field lines and not be clogged with any type of solids or scum or anything. So in a perfect world, that's what we would like to see. We'd love to get into that arena. So now let's look at our risers or access areas. I have seen some small access holes, but As you see here, we're talking about at least a 12-inch clean out, which is ideal. We just installed, I was on site for one several months back, and it had a much larger open. It was closer to, I think, maybe 18 inches or so. It was a much larger lid, which to me, I think just gives us better access into the tanks if it's needed. Now here, you know, these have risers going completely above the ground. Sometimes they're at the surface and sometimes they're just below, depending on the install. If I had to say one thing about it, is if it's not at the surface and easily accessible, please make sure to note where it is so that anybody in the future, anybody coming around, it doesn't, again, we'll touch on this in a minute, doesn't drive over it, park on it, drill through it, dig in it, because out of sight, out of mind, a lot of times people don't realize that. Okay, this is just another example because I wanted to kind of move to the right, looking at the drain field, the leach field. So when we look at what I would say just some subsurface, when we have drainage, if you're in soils that may not be as permeable, I think it's good to have some type of gravel or sand in to help with that absorption, because again, we would like to see good natural rainfall that's going to allow it to filter through, filter down, get into the soil, because it allow that soil to serve as a treatment for us as well. All right, so moving over, y'all heard me talk about baffles and what we would look at and what we would discuss. Baffles serve very much a very important purpose for any of our tanks. If we didn't have the T's in the systems, I think you would easily see clogging either coming in or going out. I think you would ruin your leach field really, really, really quickly if we did not. And pointing out here, when we think about this outlet baffle, you'll see the filter screen on there. Good friend Tom Roberts over there in North Carolina. If y'all recall, I mentioned I had very little experience with this. So Tom sent me some notes to educate myself on these effluent screens here. So I appreciate Tom for doing that. But yeah, serves a great purpose of keeping these solids and any type of scum from getting into the drain field. And then when we look at this compartment baffle, we're looking at trying to maintain those initial solids in that first chamber. And you can see it both ways. On some of the plastic polyethylene tanks, I feel like you see this method here. You'll see those plastic baffles that may be a hole slit in there. And then as far as the inlet baffle, you'll notice it seems to be a little bit higher than what is actually flowing out. Again, we like to see this as turning down so that those solids aren't backing up, you know, into our system. All right, these are just examples of the baffles we just talked, but these are in real time. So you look at the plastic here on like the top left, you see this concrete baffle here, lower left, and then the PVC T, which still serves. You'll notice this one has the like the filter screwed down in the top there. All right, same, just moving over here, looking at these filter screens. This has actually interested me. So for the systems that I've seen or have some working knowledge of, I'd like to see them install these, because to me, this is just an extra layer of protection, an extra layer of assistance. I don't see any harm in adding this or putting this in your system if you can or if it's possible. So, but as you'll notice here, you're going to have to be able to access it to get to it. Some of the systems that we go out and see on a regular basis don't have good access, such as these where you have a concrete manhole or at least a cover that can be pulled. So they definitely have to have that in place in order to pull the screen, in order to clean it. All right, y'all heard me mention the distribution box, and if y'all are kind of following with me, we're just kind of moving along. Distribution box is vital, especially if you're going to have multiple drain fields. And y'all would have heard Greg get on this earlier when we think about the volume of drain field lines, because if you're not talking with, I guess, somebody that's up to speed or just knowledgeable about the true volume of drain field lines you need, some people may just want to run one line and go, oh, that's enough. It'll run out, it'll leach. But there is I'm gonna say a method to the madness. And again, you could go back to Greg's presentation. I think it was last time, where we talked about the actual volume that you may need in your drain field based on the size of your tank or the flow. So in this case here, you're looking at 5 lines. So you use the distribution box to distribute that flow into those lines so that you get adequate absorption, and you're not having what I would call a bottleneck or a pinch point in the actual system. So as it flows out, you have enough drain field to absorb or take in all the effluent that's going out. All right, this is just another shot. Y'all may recall this from my other presentation where we're looking at the gravel and putting it in. This is really heavy. I have never actually seen one of these. I've seen simply pictures, but I've never been on site where we're actually backfilling it with gravel. I've seen a lot of sand, never gravel. Again, it is an option, and it may be in certain areas. And again, I think I'm up. So Greg, I'm at the tail end of this first little section that we've kind of walked through, just knowing the tanks, the baffles, the pieces, the distribution box, the drain field. Is there anything you may want to touch on or just say or speak to as far as the first part of this presentation goes?
Well, yeah, I'd like to add that
Come on.
I don't think we can go over the basics too much, because when I'm looking at what you're showing, it helps us to know what to expect when we go out to inspect an actual tank. There's going to be variations, but if we know the basic concept is going to be the same, solid separation and having a clarified effluent that protects our drain field, those are the 2 most important concepts. And we might see variations, but we don't have to get thrown off by that. We know that the concept is going to be the same. So it's valuable to review that.
Okay. Yeah, and Greg, I appreciate you making that point. And yes, that is, and I'm gonna piggyback off of that a little bit before I go into the next section. When we, a lot of our on-site assistance with homeowners is related to an issue with the tank, or if we've done something with their private well and we're noticing bacteria. But I'm gonna say 99 out of 100. We have zero knowledge of the tank, of the age of the installation, because it's underground. So I think Greg is spot on. Knowing these basic concepts, if it's installed properly, should have all of these components, and you should be able to line out or lay out where the tank is and where the distribution lines go from the tank, to help with why we may have contamination, why we may have an issue. So yeah, it is. I think Greg's spot on. I think it's paramount to know these basics, so whenever we go out to try to assist a homeowner or a resident, we all have an understanding of these pieces and how they should be laid out throughout the site. All right. We're going to hit on the impact of actions, and where my mind was with this section is when we think about actions of homeowners, actions of the residents, things that we may do, and then ultimately how does that impact the system itself. So from what I've seen with extension just over the years, I don't believe most people are ever, I'm going to say I'm going to use it as properly informed on how a septic system actually works, what is acceptable to go in and what is not acceptable to go in. And I would even throw myself in that category because I've got 4 kids, and they often ask me, you know, what do I do for a living? But I don't know that they're readily informed about what's acceptable and what's not acceptable, because I'm continuing to have to tell them. So I always place one key component of our education as extension professionals is educating the homeowners on these tasks and on these actions, because that's ultimately going to help our systems, whether it's a public supply or a private supply. So we're going to jump right in. When we think about clogging of these distribution systems, so when we think about how it might fail, what is that? So when we think about a clogging of the distribution lines, drain fields have solids. What we're doing, this is caused by, and as you can kind of read here, a reduced retention time in the tank. So you have these excessive solids that are moving into the distribution box and ultimately into the drain field, having excessive flows. So one of the pieces with this is when we think about excessive flows, to me, we always go back to what was the design of the system. You know, if the tank was installed expecting it to be a 2-bedroom, 1-bath house, you've added on to it, now we have a 4-bedroom, 3-bath house. You're very likely having excessive flows into the tank because the tank is too small. So there can be kind of 2 sides to that piece. Use of harsh chemicals, I know we're going to get into that in seconds, and then also the fats, oils, and greases, we'll get into that as well. But over here on the right, what you're seeing are some clogged lines, impacting the soil, where you just see the excessive, just, again, fats, oils, greases is what it looks like to me. And then the bottom, just the ponding, because it has nowhere to go. It's going to move somewhere. All right, so a couple of things about signs of this failure. When we look at the system, you have the visuals, but do realize just through these natural processes of breaking down waste, breaking down these solids, and this aerobic and anaerobic process going on, it's going to create some smells. It's going to create some methane gas smells. So you will get an aroma, especially once it's breached that tank and it's come to the surface. Soggy or wet spots in the ground. Again, I've got some more of those a little later. Standing water in the drain field, slow drains, flowing backups. When we look at, y'all heard me mention private wells. We have a private well program here in Mississippi that we run, and it's very common that when we get wells that have coliform bacteria, E. coli, and there's no clear sign around why that may be happening, but they have a septic system, so we can always start to investigate that. All right, some tips on keeping these systems working, kind of the impact. And y'all may have seen these. I've got up here reduced water flow or water volume. A lot of the new components that we see, shower heads, faucets, toilets, are low flow, so they start using less water and put less water into the system itself. Spacing out our laundry cycles. Y'all may have heard me mention this in a previous one or not, or maybe I'm just remembering from too many other trainings. But doing the laundry, I do the laundry at our house, and I'm too much OCD that when I do laundry, we're doing laundry right now, and we're doing all of it today. So I need to do a better job of practicing what I preach here. So system inspections, again, Greg got on that earlier when we talk about pumping at regular intervals. And I kept that chart in here because I don't think we can mention enough about pumping intervals, because I think that's just a key. If somebody held me down and said, tell me one thing, if you could only tell them one, what would it be? I'd say, make sure they pump it on regular intervals. No infiltration to the tank, that'd be good. Just make sure nothing's breached or broken above it. Again, we'll get on with those points in a second. Garbage disposals. Most people, when we look at systems, it is actually called an incinerator. I just don't see as many true garbage disposals anymore. I even have to tell my own kids, like, this is not meant to scrape everything into the sink. You know, put as much as possible into the trash. But when you have incinerators, they're just helping with that flow, any solids, get it moved. Harsh cleaners, avoid those if at all costs. We're working with a very natural process that has good bacteria that's breaking down these solids. So anytime we start putting in these cleaners, we can impact that bacteria, which can also kind of impact the treatment. Maintaining a good cover over your drain field, just so that natural vegetation, that natural cover crop can kind of absorb the moisture, help with any type of filtration, absorption of any nutrients that may be at the surface. Protecting against excessive runoff if possible, thinking about where your drain field is. And again, I think most installers going to be very conscious of that, so that it's at a plane of allowing just good gradual flow, not any excessive flows. And you know as well as I do, it wouldn't be a good septic presentation if we didn't mention the good old fog, fats, oils, and greases. So again, it's here, and I know y'all will all get these slides, so that's good. So y'all can keep this on there so you see it. The non-toxic to the system, the origins. We think about these fats. Does not necessarily separate some water. We think about the oils, very much a liquid. Again, trouble separating in water. The grease, where I've got listed here, residual material on appliances, solid material on pans and equipment, petroleum, moisturizers, bath oils, tanning oils. So these three combined just wreak havoc on systems. And I'm gonna say, for one, most homeowners and most residents don't realize the impact that fats, oils, and greases have on our lines. In a perfect world, they would not be introduced. But as you see in a normal scenario, fats and greases can get solid. I mean, they can be as hard as a rock, cause many clogs. It just creates issues. So I always stress to people, be conscious of this if at all possible. Do not pour these down the sink drain. I really hate it for septic systems. It's also a strain on public water supplies, and it's just a larger issue with them. Dealing with kitchen, when we think about our dishwashers, what we may do. I hope y'all like my pick here. Because dishwashers do use a large amount of water, so if you're having, I don't know that I mentioned it in here, but if you're having, because again, Thanksgiving's just around the corner, if you're having events and you have, a lot of people, we tend to wash multiple loads right there together. So if you can space those out if possible, that'd be great. As far as cleaning things from your plate, I know I'm repeating myself, but if it's not all possible, put that in the trash. Don't necessarily try to put it down the drain or into the dishwasher itself. I know I've hit on the garbage disposals, and again, everything I see, they're called incinerators. So just be conscious of that and try not to put as many solids as possible into that, into those. Laundry, I just talked about spreading those out as much as possible. I think that really helps the systems themselves. If anything, when it comes to laundry, just be conscious of bleach. I'm not saying that you cannot use it. Again, you're free to do as you desire, but do realize and understand that we use bleach, which is chlorine, as a disinfectant because it kills bacteria. People all over the world are using chlorine, whether it's a gas or a sodium hypochlorite liquid, as a disinfection for drinking water supplies. Again, all over the country, all over the world, we see it every single day. So this is no different. It may just be at a reduced percentage when it comes in the jug itself that may be used in laundry, but very much can still have the exact same impact on bacteria. So when we think about our septic systems, when we think about our tanks, we're trying to utilize the good bacteria in the tank to break down the solids for our treatment. So if we're introducing excessive amounts of chlorine bleach into that tank, we'll achieve the same thing as far as it will kill bacteria. Now again, the way chlorine works, once the chlorine comes in and it's comes in contact with bacteria, once it kills it, it's used up. Okay, so it may not kill all the bacteria, but it can have a big impact on the bacteria in your tank, and we'd like to avoid killing all of the bacteria or any, because we want to make sure we have optimal treatment. All right, I try to drive home this as much as possible. I know from a lot of our extension trainings, you know, I will tell people, if you don't remember anything else, human waste and toilet paper are the only things we want to see you put down a toilet. So think about sanitizers, you know, bath and body oils, no other products. And I like this C here, you know, if you haven't eaten it first, it doesn't need to go in the toilet. So just think about what they're designed for, what they're meant to treat. I saw a good meme the other day that I would love to share, and it had a picture of a plumber, and he's got a big stack of money, and on the side, you know, it says homeowner said, my plumber said that these flushable wipes were acceptable, and then it shows him, you know, basically making all this money. I have yet to see flushable wipes that nobody complains about. So, all right, toilet paper, excessive use can build up. So treated toilet paper with lotions, they can prevent paper from settling. Wet wipe disposal is discouraged. That's what I was just talking about. So just being conscious of excessive amounts, and in my mind, just educating people. A lot of times it's educating younger people about the excessive amounts that they don't necessarily need to put into the system. And one reality when we deal with septics, because of the flow, I like to be more conscious of toilet paper in excessive amounts with septic tanks versus public water supplies, because usually public water supplies or public wastewater systems, you're getting into the collection system a lot quicker, which is going to have larger lines and it's going to be moving. Whereas the septic or on-site, you're right there. So as it goes out, it's dumping straight into the tank. There is no large amount of movement. It's not being introduced with another large amount of water or waste. So I just think we need to be extra cautious and aware with our own on-site system. All right, prescription drugs and antibiotics. My wife is a pharmacist here, so I can tell you plainly, if you have outdated old prescription drugs, you can bring them to your local pharmacist. They will accept and they will just discard of those appropriately, legally, properly, but do not put them down a toilet, please, because what you ultimately do is you introduce them into the septic system and can very possibly get introduced back into the leach field, which ultimately goes into the groundwater that can be drawn up by a private well or a downstream well. So please, for whatever cost, don't put your prescription drugs into the drain, because as I've got noted here, it kills microbes living in the system, increases maintenance, you know, additional treatment components may be necessary. When we think about the prescription drugs and what they're designed to do or their purpose, you think about the impact it may have on the bacteria that we have in the system, in the tank, the septic tank itself. All right, so next slide. If there's been one topic related to septic tanks that I get, I'm gonna say, a lot of questions about and a lot of somewhat of uncertainty. So even though, and y'all heard me say it before, I'm not a huge fan of using additives to go into the systems like the Ridexes, just because nothing that I've seen really says, hey, you've got to do this. Septic systems, on-site wastewater systems have a very natural process of being able to break down. The one caveat where I have said, hey, I think it can be worthwhile to put some additives in is if you have had a flushing out of the tank, killing off of the bacteria, and you're trying to reintroduce some bacteria into the system to help with the breakdown and the killing. That's my one caveat as far as an exception, but I just really look at it from a dollars and cents standpoint. If you've got a properly installed septic tank and you're treating it properly, maintaining it properly, and you're only putting the appropriate things in the toilets or in the drains, I don't think you need to spend the extra money for additives. So I will move on. So looking at cleaning products, and this is one of those items about like the color twist ties on the breads. You know, a lot of people don't realize that those signify a day. So if you know the colors, you can know how old your bread is on the shelf. So that may be a conversation for another day, but I'm getting into the danger warnings and cautions on labels of cleaning products that you may see that go in the drain. So when we hit danger, it means this chemical will kill the bacteria and its use should be minimized or eliminated. Warning means limited use should have a minimal impact on the system. And caution just typically means the product will have a little effect. So just be aware that those are not just synonymous, like they do serve a purpose and a meaning. All right, moving over here to drains and drain cleaners. I hope y'all notice the picture on the left here is a gentleman that has the little cleaner. It's there's about another foot on the end of that as far as a drain cleaner that pulls the clogs out. So for all of you out there in radio land that are listening today, y'all may already know this, but if you have girls, I've got twin high school girls, and I have to clean out shower drains quite often for a lot of hair. They have long hair, so they tend to clog drains. But I think this method on the left of actually pulling it out and then flushing it with good hot water does a much better job because you're actually getting the product out. And then plus from the Drano, you're not introducing a toxic chemical into the drains and ultimately into the tanks itself. All right, I'm gonna put a few of these out. Yeah, okay, so all right, so factors that inhibit the drain field performance. So we're kind of moving out into the system. I know we keep kind of hitting on this, fats, oils, and greases. This is one of the things that Greg leaned in on as far as impacting the biomat and decreasing performance of microbes. And then, failure to pump the septic tank when needed can result in solids moving out of into that drain field and disrupting our percolation or absorption. Adding solids from the sink or the garbage disposal can lead to solids accumulation into your tank and then ultimately into your drain field. So the results from that, you can see some decreased treatment, decreased percolation, not going into the soil that come to the surface for ponding. Your aerobic process can be interrupted, and then sewer backing up, either into the home or coming to the surface. All right. All right. So when we think about not having the scum layer, the solids removed, solids removal is accomplished by flotation and sedimentation. The middle zone is clarified effluent, solids with less density than water float to the top, and those solids, of course, heavier that move to the bottom. Scum layers should be developed after 6 months of operation. Scum layers ideally at least an inch thick. So looking at this, when we think about not having this scum layer, and as you see from the picture to the right, or the picture at the bottom, but I'm thinking about to the right, the effluent baffle is missing, which possibly means that scum layer has gone somewhere, potentially into your drain field. High flows or turbulence, when you hear me talk about system being washed out or flushed out, you may see that. Emulsifiers, overuse of phosphate cleaners, fabric softeners, degreasers, and then brine from water softeners. And you do see some softeners, especially in our private well communities, that there's some type of treatment they're trying to put on their water. So some of y'all may fall into that category. All right. Yeah, I'm sorry. Toxins and disinfectants should also be used with caution, since they can cause damage to beneficial microbes that we have. Yet, so y'all heard me talk about the multiple things that may be introduced. You know, the chlorine, the Drainos, the killers, the prescription drugs. These may all have an impact on the good bacteria that we have. All right. So, failure to pump our tank, again, I don't think we can drive home enough, and y'all heard me say that already. If I had one thing to say, I would say that. So failure to pump our septic system, solids enter and clog the drain field, which to me is paramount, that we need to try to keep that drain field clean and open. Treatment effectiveness is reduced because there's less hydraulic retention time due to smaller effluent zone. So, you know, you think about that percentage. What percentage of that first tank is filled with solids? And there's a method to the madness there. If you're at 25%, 30%, 50%, just knowing where that is. And again, y'all heard Greg last time talking about the measurement, where they'll actually go and measure the sludge level layer in the bottom of the tank. So high cost of repair or replace drain field, again, it's paramount trying to keep that clean. Harmful gases and aerosols are produced. You heard me talk about that earlier. You have a natural process going on where good bacteria are breaking down these waste solids, and it does create this methane, the hydrogen sulfide. So you can smell that very much so. I know I'm a hit on this, but you can never, I don't think, preach as far as the tank pumping as much as possible. So here we're looking at this. How do you calculate? How do you figure? There truly is a method to the madness here. So in this scenario, and again, I grabbed this from Greg, where we made a look at, we got 4 people in the household, it's 1,250 gallon tank. We're clearly looking at we need to pump every 3 years. So, and again, you can use this matrix just like that. And y'all heard me talk earlier on the size of the tank and how that may impact when that is, because you just have a larger volume to hold of waste coming from the house, which allows for a little more detention time. Hopefully the solids settle out. So I'm always a proponent of upsizing a little bit, just for potential growth and thoughts. And again, this is, I don't think we can, I almost didn't put this in, but I don't think we can mention this enough when we think about our pumping recommendations, because I think it's key to the life cycle of a septic tank. All right, I got a couple of do's and don'ts, and then I'm gonna let Greg jump in here on this piece of, so just from the do's standpoint, this again, when we think about the impacts that we have on here, you know, knowing where your septic tank is located, I think again, y'all heard me say that over and over again, just because it is a critical piece. Plus, if it's harmed from the surface, the impacts that it can have ultimately on your wastewater treatment, which you've got to have every single day. Have it inspected and pumped. We've talked about that. Keeping records of repairs, inspections, all that, just for future use, either for yourself as a reference or for a future homeowner. Cleaners, detergents, just be aware of those and the impact it may have. trying to reduce any harmful cleaners or detergents if possible. When we think about what's on top of our septic system, septic drain field, we would love to have just a grass area, some type of cover crop, easy to maintain, but not compacted. Nobody's driving on it, parking on it, living on it. Just being aware of our flow, water into it, as far as also water on top and around. All right, some don'ts. Again, y'all hear me kind of preach on this. Don't treat it as a trash can, because it's not. No, in the mornings, nobody should be putting Q-tips. Nobody should be putting anything in a toilet that they don't want to get into the tank. And then from a sink standpoint, put as much food, fats, oils, greases also into the sink, just so that it's not, into the trash can, so it's not going into the sink. Talk about this, don't build or pave over the drain field just because you need that absorption, you need that percolation, you need that to assist the system. So Greg, I know we're pressed a little on time. So if you do have anything, just talking about the impacts on the tank, if you want to say a quick word before I move to the next section.
Yeah, 3 super quick points. Bleach, you talked about bleach. That's neither a scum or a solid or a sellable solid. So it's very likely that's going to be able to go right straight into the drain field and harm the bacteria where we need it to work most. The pharmaceuticals and personal care products, even activated sludge plants many of those drugs are not able to be broken down by even advanced treatment. So those are very likely to make it all the way down to groundwater in a septic. And the third point is that a small leak, like a leaky toilet, if it's leaking 24 hours a day, that can add a lot of extra unnecessary hydraulic overloading to your system.
All right, thank you, Greg. And yeah, I appreciate Greg reiterating those points, just so everybody is aware of that. So we're going to touch on how proper functioning on-site wastewater systems, how poor functioning on-site wastewater systems can affect the landscape. And again, our mindset when we talked about this, we're truly talking about the physical grass landscape here. So I have some pictures here, and we're going to kind of walk through them just so you can see. We'll kind of talk through what we're seeing and why we're seeing it. So this is one, and you may remember, this is a perfectly laid out drain field. It's beautiful, but you can clearly see it. And if any of y'all caught our blog post from a couple of months back, I talk about this, just to kind of a silver lining or making lemonade from lemons in the dry seasons, is that you can start to pick up on if you have any issues with your wastewater system, either at the tank or around it or within your drain field. So again, do realize we have some nutrient loading with septic. So again, that's always just food for the cover crop that's out there, whether it's just a lawn. But in this case, you're seeing that lush green, potentially from some clogging into the drain field. So you're not getting, I guess, perfect percolation. You're actually getting some moisture coming to the surface here. All right, moving into, this is where we may see just some, for one, it seems like it's just, there's no percolation at all. I think in this area, when I got this, we're looking at a tank that is bleeding into a creek, and you're just seeing excessive nutrient loading, and you're seeing just algal blooms or just algal growth in this area. So not good. And of the probably a dozen times that I've called and gone out to homeowners with issues, this is their land, and then they look up the road and they're like, well, there's the person's house and tank that's not us, that's basically straight piped or overflowing into our little creek. So you can see some nutrient loading there. Here, I would imagine you've probably got a distribution box that's completely clogged, so it's not able to go anywhere. So all your water simply coming to the surface. As you can see, you have this extreme black, so it's very much just septic. So I would imagine you've got a wonderful smell right here, and you have some very lush green grass growing as well. Makes it very attractive. All right, this, as you see, you're simply getting the lush green, dark green vegetation. Probably one of the most interesting sites. I went to one time. There was a lake that was getting a lot of E. coli in it, and everybody adjacent to the lake was on septic. And I told the HOA folks, I said, it should be pretty easy, you know, drive around the edge of the lake and you should be able to find, you know, some excess vegetation like this. You'll notice it, you know, basically leading into the lake. Because again, these are clear. This is pretty common if you have an issue with the tank. We're not getting proper treatment, proper flow, proper absorption. So this is another where you're simply getting the very much liquid coming straight to the top. Again, you're probably having a clog somewhere, whether it's the effluent pipe trying to go out is clogged, or the actual distribution box is clogged. There is a reason you're not getting the flow moving away from the tank itself and it's coming to the surface. All right. You've heard me talk about having a cover crop, whether it's grass, you know, in some areas it may be something other than grass, but there's a reason that we have that there so that it can kind of take up the water, take up the nutrients, stabilize the soil, prevent any type of erosion. And again, just kind of harping on this, don't park vehicles on drain fields because you just lead to the compaction of the soil and potentially cracking or breaking of the drain pipes themselves. Hopefully not. Not having anything built on top of. Surely we're not going to put any type of driveways or buildings on top of them. No woody vegetation over the drain field. And when we think about woody vegetation, to me, I'd be more concerned about roots and growth and those getting into your lines and clogging them from that area. All right. Talking about spray fields for just a second. It, to me, is important to realize that, as I've noted here, this is not drinking water. This truly is effluent. It should be treated. We would love to think it's treated. A lot of what I see with these when they're installed, there will be a contact tube where they will put little chlorine tablets, and this is no different than what we may see with a lagoon system treatment where you're using tablets as a disinfectant. So you're having, as that flow comes across, it's rolling over the tablets, so it's coming in contact with some chlorine. You'll have a small detention piece, hopefully, before it goes out the spray fields. But nobody is going out and grabbing residuals off of this, so we don't really know how well it's treated. So I would just always use caution with these spray fields and just realizing that, hey, this is not drinking water safe. The reason you probably have these is because they did a perk test at your site and you wouldn't get proper absorption, so you're having to put it out in this manner. All right, so again, I'm kind of reiterating this, especially from the spray field standpoint, making sure that you have a good, healthy grass or cover crop out there to take up the water and nutrients and stabilize the soil, prevent any type of erosion. All right, I know we hit on this earlier, but I just wanted to hit it from a landscape standpoint, but the subsurface drips, I have seen, I think, one of these in my career dealing with systems. This is not something common that I see in Mississippi at all. So this is more of a graphic related to it. So this is going to be real-time subsurface strip laid out, and then ultimately back over with grass inside or dirt inside to cover it up. So I know, again, we're running a little on time. I hope everybody's okay, but from a landscape standpoint, Greg, do you have anything you want to say or do before I go on our last few slides where we just have diagrams on wells and how that groundwater is impacted?
Okay, well, maybe I'm a little preliminary on this idea, but the average 3-bedroom house, we estimate about 150 gallons per day per bedroom. So that's 450 gallons per day going in to an unconfined aquifer, basically. If you have 100 homes, times that by 100, 45,000 gallons per day going into our aquifer. We'd like to know that that effluent is treated sufficiently. And that's the only point I'll add. It was an excellent presentation.
Well, we'll segue into this. So as y'all probably heard me talk about, I got into dealing with Onsite mainly because a decade ago, as we were doing a lot of private well work and just well work in general, drinking water, those people were also the ones with septic on-site wastewater. And we think about how does that impact the groundwater, or what do we need to know about it? So I felt like I wanted to put this here, just thinking about how and kind of why we have this, so we're moving into a manner of trying to treat the individual household effluent so that it moves into a good drain field and can be absorbed into the soil and can receive some form of treatment. So we're trying to have this very much natural process of wastewater treatment at the home, at the residential level, but also realizing, as you notice I have in this diagram, this well, they are connected. There is a connection between our soil and our groundwater, that water table, and then depending on our well and our well depth, they can be very connected. So that's why in most states you'll see there's a minimum standard of distance between your well and your septic, between your well and your drain field. And then I even tell people, hey, there are minimum distances, but I would recommend get as far away as you can, because I think that only reduces your chances of some form of contamination. So moving from here, to me, we're using this as this picture of the home, the wastewater source, into the treatment, and then hopefully into our effluent delivery, the leach field, and you have the infiltration, the treatment, the percolation into the soil, and then down, and we hope that it ultimately reaches into the groundwater water table there, which we all use in some form or fashion, whether it's through our ag irrigation or it's through an individual home well, or does it feed into an adjacent river, lake, or stream. But there is an impact. That groundwater can move, and very likely does move, into something that we touch or come in contact with. And then ultimately here, when we look at the wells and how they are connected into that water table, into the groundwater, and again, we see this a lot from our private wells in Mississippi, which typically range in I think our average depth from all of our years of sampling is about 200, 225 feet, which to me is really shallow compared to our public supply wells, which a lot of times range in the 750 to the 1,200 foot range. And they may be getting down into more confined aquifers. So from that arena, if we're dealing with private wells, which a lot of people have that are on septic, be conscious of this, because it's very likely that your well is shallow or more shallow than the public supply. And it can be impacted by our on-site wastewater system. So just want y'all to be conscious of that and realizing that there is a relationship between our private well and our drinking water source and our on-site wastewater system and its treatment. All right, so that is me. I know I have run a little over. I apologize about that. But if I did go, I guess, too fast or too much, I know that there can be some communication. I know we have Owen and Christy and Avery on here that may receive questions and relay them back to them. But Greg, do you have anything you want to add before I turn it back over to Owen? And
I'll be here if you want me to chip in on any questions that have come in.
okay, Owen, I'm turning it back over to you, my man.
Okay, sounds good. Just for everyone in attendance, if you need to go, that's no problem. You'll still get full credit. We're just going to run through there's about 3 questions that we were going to answer. So the first question that we ended up getting was, can having only an effluent filter be a substitute or no interior for no interior?
So having an effluent filter, can that substitute for having no interior what?
Baffle.
Ooh, I'm going to right out of the gate say no, because I think you're putting too much dependence on that filter itself. And I think about the only way you could possibly allow that to work is if you're checking and cleaning that filter often. But I would love to pitch that to Greg, get Greg's input on that as well, please.
Yeah, I think you hit it, Dr. Barrett. There's going to be a little bit of scum that develops on the surface of that second chamber, and that's going to, if you just only have a filter to keep that out of the outlet T, it's just going to plug up the filter really fast. So it's a good thought, I think, thinking out of the box, but I think it would be asking for trouble.
So the second one has a little bit of context to lead into it. So there's been a huge surge in claims that dishwashers use less water. Person says that they don't fill their sink. They wet their sponge, wash many of the dishes, and then rinse them all at once. Does a dishwasher really use less water? They're skeptical.
Does the dishwasher use less water than what?
They're just skeptical that the claim is true.
That dishwashers use less water than washing it in the sink yourself?
Mm-hmm.
Is that what they're saying?
Yes, I think so.
Okay. Shoot, I think that's one of those, it depends. Depends on who's washing the dishes, because it sounds like the person that washes it is very water conscious, whereas a lot of people that I've seen hand washing dishes, the water is running continuously while they're washing the dishes. So that may be the claim why dishwashers can use less water, is based on that maximum water usage. That's just my speculation in there, but I do think they can be more efficient just because they're very directed. It's very pressurized. I mean, it serves that purpose. Greg?
Yeah, I might add, I think EPA has the Water Sense site where you can actually go, and I think you can compare brands to see what appliances actually use as far as how many gallons of water.
There
That
you
might be
go.
something.
Okay. The last question asked, how do you clean up something like that? And that was in reference to the malfunctioning system that had the bog-like conditions. The first, I believe.
The one that had what now?
I believe it's the first one that you shared, the first picture of malfunctioning on-site systems.
The ones where all the field lines were showing in the yard.
Oh, sorry, the one after that. My apologies.
Hold on, I may have to, pardon me, I may go back if that's.
That one.
Like here?
One. Yeah.
But for one, if you can stop the flow into the area and actually have it passing through treatment, that would help tremendously. Because this here is very likely it's not getting any treatment at all. You're simply getting this huge nutrient load into this stream, little stream or creek here that's causing it. So restricting the flow or having it actually treated before there's any flow hitting this area would greatly reduce this, if not completely eliminate the algae bloom, algae growth.
Fantastic. I think this is a good way to wrap it up.
Okay.
I was left by someone who left, wanted me to let you guys know that it was a very great and informative presentation. So with that, I wanted to give a huge thank you to Jason and Greg for sharing their expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following this webinar so that we can better know your thoughts on today's session, which will help us to plan future webinars on topics that are important to you. So thank you again, and we hope to see you at future EFCN events.
All right. Thank y'all.